Greetings, fellow Carbonauts! Nerdy Spaceman here, in for another installment of A Beginner's Guide to Kerbal Space Program. And in this episode, we're going to go ahead and build a little bit more complicated rockets, and we're going to try to see if we can get much higher up than we got to before. So first things first, I'm going to go ahead to the Research and Development building, and I'm going to look at what we have available. Now, we've got two tech trees available. We got bigger ones here that are more expensive, but I can't afford those at all. We've got two here that are potentially within my budget. I've got one that has 20 science points and the other one has 18. Unfortunately, that's one extra science away from what I have, so I have to pick one of them. And I'm going to go ahead and pick the general rocketry, because general rocketry gives me bigger engines, and bigger engines is always better. Bigger fuel tanks too, so that's always a good thing, and even bigger solid fuel boosters, so that's excellent. So I think that's what I'm going to go ahead and do. I'm going to do that. Right on. Okay, I'm going to go ahead and close this, and I'm going to go back to the VAB, and we're going to start building bigger rockets. Now, I'm going to go ahead and load the Pike, because it was a good starting rocket. It was a good base. But I'm going to get rid of the solid rocket booster here in the bottom, and get something a little more reasonable. I'm going to go to the fuel tanks, and I'm going to add a different type of fuel. This is called liquid fuel and oxidizer. These are fuel tanks. They carry nothing but fuel, but it's different from the solid fuel, which was what these ones were. The Hammer, the Flea, and the really big one, the Thumper. These are all solid fuel boosters. They come pre-built with an engine and fuel and all. It's all one big package. So they're different, but once they're switched on, they burn and they can't switch off until they're all the way out of fuel. So they're different than from the liquid fuel. The liquid fuels usually have engines that can be throttled, meaning you can choose to give a little bit of gas or pedal to the metal, and they're slightly different from the other engines. And they also have things like gimbaling, and they're more fuel efficient because you can actually build multiple fuel tanks and attach them onto each other like so. Now what I can do is, instead of attaching them one by one, I can actually, here, I'm going to get rid of these, I can alt-click and add more fuel tanks. If I alt-click on the same one, I'll add two more. If I alt-click on the science, it's going to add the science thingy, but I don't know if I want to add that. That's a bit excessive. But again, that's the alt-click button, is it selects the item you're hovering over, and every item below it attached in that order, and it creates a duplicate of that item. So that's the alt-click button. And what I'm going to do is, I'm going to put two of these. Two of these should be just fine. Now, when you connect two of these fuel tanks together, you don't have them separated by a decoupler, because the decoupler, you can actually go to structural, and it'll say there in orange text, no fuel crossfeed. That means that it won't connect the fuel tanks. Right now they're connected, so they'll act as one fuel tank. It'll draw from the top one, and when that one's empty, it'll start drawing from the next one down. If you say put a decoupler over here, and then grab another fuel tank and put it down here, it's not going to drain from these two until you get rid of this decoupler and then drain from those two. But for now, we're not going to worry about that, because for every fuel tank, you must have an engine. In very particular, you need the liquid fuel engines. You can see them here, there's two of them. One of them is the Reliant, and the other one is the Swivel. The Reliant is a good lifting engine. It's good to get you off the launch pad and flying. The Reliant is slightly more fuel efficient when it comes to flying through space in the upper atmosphere. It also has gimbaling, which gives you control over the craft you're flying over. It gives you the ability to steer. I'm going to go ahead and put the Swivel because it's got more utility. The Reliant is more of a power horse that just does nothing but lift your craft off the ground and get you going pretty quickly. It doesn't give you much control. So I'm going to go ahead and put the Swivel down there. And I'm going to go ahead and then do a stack decoupler. And when you put it on the bottom of an engine, it actually covers it up neatly with these fairings, so it protects the engine on the way up. And now, this whole package is independent. I've added this line here, and this prevents any fuel from leaving the top stage and messing with the bottom stage. But that's quite alright, because I'm going to go ahead and put the Hammer solid fuel booster, just to get me off the ground. And now I've made a two-stage rocket. What that means is that I've got the first stage is the solid fuel booster. When this runs out, I have decouple, disconnect, leaving me with this upper stage. I will then activate this engine, the swivel, and I'll burn through all of the fuel, and then after that I'll decouple that as well, and I'll be left with nothing like this. And that is how you make a multi-stage rocket. Now again, just as usual, we're going to build our rocket and make sure our stages are correct. We can do some interesting tricks, like for example, I can take this decoupler and drag it onto the same stage as this engine so that they both get activated at the same time. And that makes sense. When I run out of fuel from the solid fuel booster, I want to decouple and switch on this at the same time. And you can do that by staging them together. Now, I don't want to switch on my parachutes at the same time as I decouple, because Lord knows where I'll be flying at that point, and I could potentially destroy my parachutes in that way. So I'm going to go ahead and just leave them separated like this, but keep these two combined. Now, one final pre-flight check, and I don't have a center of lift. So as usual, I'm going to go ahead and add 4 basic fins on the bottom, with the 4-way symmetry, and that's excellent. Now, remember, every time you stage, the properties of your rocket change as well. So when I stage from here, you will see that I'll lose my center of lift. So I need to add another 4 fins to add that back into the rocket, and everything is hunky-dory. I can return this, and you'll realize that the center of lift actually increased in height. For example, if I get rid of these fins, you'll see how the center of lift falls down back to these fins. But when you add the fins again, it gets split between the two. This is very important, and you have to be very careful when building rockets, as these will change. Again, the same order, you want the center of mass, and then the center of lift behind the center of mass, and the center of thrust anywhere so long as it is lined up perfectly vertically, perfectly underneath everything else in a straight line. And this is going to be an excellent and very stable craft to fly. I'm going to call this the Lance. It looks like the Lance to me. And I'm going to go ahead and save it. Finally, we're going to go ahead and make sure that Bob is in there instead of Jebediah. That sneaky Jebediah. Because we want that science. So I say, let's launch. Okay, so very important about launching is, especially when you're flying rockets that go really far, which is what we intend to do, is you want to have some control over your rocket. I'm going to go ahead and quickly discuss what all of these things do before we launch so that you'll know what's going on. You're already familiar with Bob. The IVA button here, when you click on that, that actually gives you a view of the inside of the capsule. And you can, if you just click the right mouse button and you can move it around, click again and it'll lock in that view. And then you can double click on the window to see out the window, and you can actually even see Bob here. Hey Bob, how's it going? Which is pretty interesting. Then you can push the C view to bring you back, and the C again to bring you all the way back out. But that's just the inter-vehicle activity. It's interesting, it's cute. It gets a much better view when you're flying planes, because the cockpit windows are much bigger than this tiny little window. Next, we're going to talk about the staging. You're familiar with the staging and which order they go to. And you can drag the staging around just like you can in the VAB, but generally they should be correct before you launch. At least if you make a mistake, you can always revert. What more importantly though, you've got the views down here. You've got your roll, yaw, and pitch. And this will tell you how much you're applying pressure in those different areas. It also tells you the current stage, and these buttons will give you different views. The docking will be ignored for now because we will almost never use docking. It's more particular for specialized uses. But the orbit map actually brings you out to the view that you get from the tracking station. This will be used for planning out trajectories and flights, and you'll see that you can actually hide and show the nav ball inside here. And you can even fly in this mode, and we'll just talk about it in a moment. You can then push the the M key to bring you out of the map mode and back into flight, and you can toggle that again. I can go back to the staging, and now we have control of our craft. We have the counter and the warp thing here. This is for time dilation and measurement purposes. You won't be using that too much, except for noticing what warp you're in. You've got the altimeter and information here. You've got your altitude measured here on the altimeter. You've got a barometer that measures pressure. You've also got a altitude counter, which actually counts how far your vertical velocity. So you can be negative vertical, which means you're falling. So anytime this line is underneath, you're falling. And it's actually logged in scale. So you'll first get to -5, then -10, then -100, then -1000. So it'll actually be logarithmic in that regard. Up top is the same scale, but positive, meaning you're going up. So you'll be going up at 5 meters per second, or 10, or 100, or 1,000 meters per second. That's what this is. If it is perfectly at the 0, you're either not moving, or you have a perfect orbit that makes it so that you're neither gaining nor losing altitude. And that is how you can tell whether you're. It's very interesting, a little bit of information. You've also got lights, gears, and brakes, but generally we won't be using those until we actually get those equipment, and I'll talk about that then. You've also got the Space Center button and the Recover button. You're familiar with the Recover button, but keep in mind it only exists when you're not moving and landed on the surface of a planet, or on the surface of Kerbin in particular. The Space Center you can always access from any time, so that you can, for example, launch a rocket and then go to the Space Center to leave it up in space without having to revert anything. For example, space stations, the only way to leave would be to go back to the Space Center using this button. Finally, you've got the resources and contracts. The contracts is going to stay empty because this is science mode, and the resources is actually going to give you a list of all of the resources available on the craft, and when you mouse over, it'll actually highlight them and tell you how much you have of each of those resources. For example, if we have 2 fuel tanks, you can right click on them and see how much fuel we have in each one, but the number considered here in, for example, liquid fuel, it is combined total. Here it is only 90, but since we have 2 of them, we should have 180 liquid fuel. Anyways, that's a good rough overview. Now when you click this button, it locks it in there so you can keep an eye on all of your resources. Now finally, the most important of all is the nav ball. You can fly completely using the nav ball and not anything else. It is extremely useful. This isn't found in almost every single airplane that you'll ever see, and also in spacecraft as well, because it is extremely useful. On the right side, you have your G counter. This is for information for how quickly you're slowing down or accelerating. That is the acceleration field. You've also got on the left here, you've got your throttle. That is controlled with the left shift, makes you throttle up, and the left control makes you throttle down. The Z key maxes the throttle, and the X key kills the throttle. You've also got other keys that are useful. The T key gives you SAS control, which is a stability enhancer. And then the R key gives you RCS, but we'll talk about that later. They're controlled only by hotkeys. You cannot push them as buttons. But for now, what we're going to do is we're going to turn on the T key for SAS control and hit Z for a max throttle. But that won't affect us until we get to the liquid fuel stage, since the solid fuel is always on and cannot be controlled once it starts burning. But I say, let's burn. So space starts us off, and we're flying. Since we're much heavier, we have a much slower start, but we have twice as big and more powerful solid fuel booster, which is able to push us way off the ground. Since we burn for longer, we actually generate more heat, and you'll notice these little bars will start showing up. Those little bars are actually heat-based bars. It means those parts, those fins right now, they're overheating. Now, I've run out of solid fuel, so I'm going to go ahead and push the space button to stage. And now we can actually control the craft because we have an engine that lets us gimbal. I can then point it, and you'll see the engine turns for us, and we'll be able to turn. Now, unfortunately, it is very powerful, and we're moving in a very strange direction. And here we are, we're now moving at 45 degrees, and we're flying very high up. Eventually, when we get past this atmosphere, when we leave into the dark blue, we'll actually be in the upper atmosphere. But you can tell right now we're going so fast that we're triggering overheating effects. This is potential to burn up our craft, and that means that either our craft has got an engine that is way too powerful, or we can afford to put extra fuel tanks to get us more heavy to counteract that power, and also actually have the engine burn for longer. But now that we've gone and run out of fuel, and we're now officially flying up into the upper atmosphere, I'm going to go ahead and do some experiments. Like the mystery goo, it is going to tell us that we're in the upper atmosphere. And that is an excellent place to be to collect science. I'm going to do a crew report, and I'm also going to do a Science Bay Junior report. And while I'm up here, I'm going to also hop out and do an EVA report. I'm going to keep that data. Now, I'm going to go ahead and collect the data as well for the mystery goo, inch my way down, and collect the data from the Science Junior as well, and restore both of them. Now I have all the data, and I have an EVA report as well. I can actually right-click on the crew pod and take the crew report out of the crew pod. I'm now holding every single bit of data and boarding it again. This is essential for resetting my crew report. If I don't take the data out of the crew pod, the crew report stays active, and I can't do another crew report without overwriting my data. That's not ideal, and I would like to keep my crew report for later use, so I have to take the experiments before dumping them back in. But we have 4 experiments, and that should be quite alright. I'm going to go ahead and stage this, because that's just dead weight for us now. And I'm going to turn off the SAS, and now we're spinning freely and waiting for us to come back down. We've gotten pretty high up there, and now our altimeters change and we're officially falling. You can also click the M key to see how that changes our trajectory, and here you can see that we've gone up, hit our highest point, and we've fallen down. Our apoapsis is our highest point in our flight. And this is an accurate measurement of where we're going to fly if we keep the speed as it is. Unfortunately, as we fall towards the planet, it's actually changing our speed, and it's going to change our trajectory a little bit. So this isn't an accurate measurement, like very, very precise. It is accurate, but not very precise. That is because these speeds are constantly changing when you're in the atmosphere. Once you're out of the atmosphere and in space, this is an extremely accurate and precise way of measuring where you're going to be in space. But for now, I'm going to go back to the map mode, and you'll notice that we're flipping around in all kinds of different directions, because we weren't pointing this way on the way back. Now what's happening is the air is pushing us around, and our center of mass is actually more towards the top. What this means is that our craft, the center of mass up front, with less mass on the bottom, means it's going to want to point itself in that direction. This is not ideal because as we re-enter the atmosphere, the brunt of the heat is going to be taken by our parachutes and our science equipment and our crew pod. That is not good. So to fix the problem, we're going to switch on SAS with a T key, and we're going to hit this button, which is the retrograde. This will point us always in the opposite of the direction we're traveling. And just in time, here's the re-entry effects, and the heat shield can then take the brunt of the energy. That is what the point of the heat shield is. Now, when you have SAS on, it burns your electric charge. So a lot of the time, you want to turn on just on stability assist instead of retrograde, and manually control it so that you're pointing the right way. It burns less electricity than if you were to do retrograde. Now that we're coming into the atmosphere, we're slowing down, we're at Mach 2. When we hit 300 meters per second, we'll be at Mach 1. And you can actually right click on these parachutes and it'll tell you that it is unsafe to deploy your parachutes because we're moving way too fast. When this says risky and then safe, it is now safe to deploy your parachutes, and you can push the spacebar and it'll open all of your parachutes. At this point you can switch off the SAS and you'll be guided down to the planet safely. And here we are, we're falling down. Now while we're doing this, we can actually collect some experiments. I'm going to do a crew report, and it's going to say flying over the Kerbin's waters, because this is a new biome for us. If we do the mystery goo, unfortunately it is not going to let us because it's just going to assume flying in Kerbin. This is because mystery goo and science bays can't differentiate between the biomes. Crew reports and EVAs, on the other hand, can. So if I hop out with an EVA report, it'll tell me that I am flying over the water and I'll collect science for it, which is excellent news. Again, if I want to reset my crew report, I have to take that data out and then board again to store everything back in or store it manually. Now that we're falling down with the parachutes deployed and we're falling slowly, I can again time warp as we fall down and land in the water at a faster rate. And ideally, you would want to slow the time warp back down to regular speed right before splashing, because physics sometimes in this game does weird things at high warp, and it could potentially break your craft, which is just not ideal. So we're going to go ahead and speed that up. Eventually, we're going to get closer to the surface, and we'll be able to land. Once we land there, we'll be able to collect more science from the water, because this is a brand new biome, and it's great for us to be able to collect new science from different places. Now, we're getting close to the water. I'm going to go ahead and reduce my speed down to 1 times on the warp, and we're going to splash down and tip ourselves over, and I'm going to collect brand new science from the water itself. So this time, it actually knows it's in the water because we're splashed down. And I can collect the science and get more science. Do a crew report, hop out and do an EVA report. But again, I am now holding onto the ladder. That is going to count as flying over the water, and we've already have flying over the water. So we're going to reset that experiment, push space to let go, and we're going to be standing up on the craft, and now we're actually going to be considered in the water. So we can take surface samples and an EVA report, and we can keep all that data. Then we can push B to board the craft, and we can recover the vessel and collect all of that science from 2 different biomes. And that is the key to resetting experiments, and we're going to collect a whole bunch of science. This is what's going to get us all the way up to orbit. And that is all we have time for. Sorry this video ran for a little bit longer. This is Nerdy Spaceman. Stay safe and fly far.